Do you all remember him? For those who don't, meet Bob the Builder. Bob finds immense joy in building and construction. Bob loves consulting researchers for designing his buildings. Ladies and gentlemen, allow me to share my research on earthquake ground-shaking predictions inspired by conversations with Bob. In our first meeting, Bob excitedly shared his latest project, designing the iconic beehive building in Wellington, but then anxiously asked, how much would my beehive shake during a future earthquake? I explained to Bob that answering this involves obtaining the key characteristics of this danger. How strong would the earthquake be? How fast would it shake back and forth? And how long would it last? He eagerly asked, can you give this to me right now? I told Bob I need time to capture the physics of earthquakes in my computer models, right from the source where the earthquake begins, through the path the waves travel, to the soil on which your building sits. He cut me off there. That sounds too difficult. I'm out of here. Bob went ahead and constructed his beehive in the best manner possible. Then came the Kaikoura earthquake, which significantly impacted Wellington and caused millions of dollars in damage to this beehive. Look at Bob, angry and frustrated at the engineers for providing inaccurate information on this earthquake. Why was Bob given information? Apparently, engineers rely on rules of thumb that may not represent Wellington. And these methods haven't been tested against historical Wellington earthquakes. My PhD research exactly addresses this problem by modeling the physics of earthquakes and testing these models against past earthquakes. Using 500 earthquakes recorded across 200 locations nationwide, I compute the differences between my model and reality. By examining these differences, I find patterns such as how houses located on mountains shake differently from those on flat ground. With these insights, I have developed a model that more accurately reflects earthquake effects across different terrains, resulting in predictions much closer to reality. Bob is hopeful about my PhD, confident that my models will enable him to design earthquake-resilient houses for New Zealand. In closing, I don't predict when or where the next earthquake will happen, but I'm helping us accurately answer how much will the ground shake when it happens. Thank you.